We have another lab assignment from section 3.9, and here we have a trough that's 16 feet long, and its ends have the shape of an isosceles triangle that's 3 feet across on the top. It has a height of 1 foot, and the trough is being filled with water at a rate of 14 cubic feet per minute. How fast is the water level rising when the water is 8 inches deep? So this is, we're in feet now, 16 feet long, 14 feet cubed per minute. And so now we go to inches, so we have to make sure that we transfer that into feet. So let's set up the problem. Let h be the water's height and b be the distance across the top of the water, not the whole trough, but just the water. So when the trough is filled up, the distance across the top of the water is going to be 3, but when it's not filled up, it's changing, so we're going to call that b. Using the diagram below, find the relationship between b and h. So 1 and 3, so using similar triangles, we have the big isosceles triangle here with a base of 3 and a height of 1, and so it's going to be the base over the height. It's going to be b over h. And once we have the relationship between them, we can find the volume and then try to express one of these things in terms of the other. So the volume is going to be 1/2 base times height. That's going to be the triangle that gives you the area. And now this trough is 16 feet long, so we're going to multiply it by the length L. So it's 1/2 base times height times L, which is 16 feet long. That's our 16 feet long. And then we're also going to take advantage of this relationship between the base and the height. So it looks like there's an h here, and then the base, if we solve for the base, is going to be using this equation 3 over 1, so that's 3 is equal to b times h, or b divided by h. If we solve for b, then that's going to be 3h. So this is the base, that's b. So 3h times h is b times h. So what do we have left? We have 1/2 times 16, and that's going to be 8. So let's put all this stuff together. 8 times 3, and then h times h. So we're going to get 24h squared. So our volume can be expressed as 24h squared. Now we're going to take the derivative of this with respect to t. So dv dt is going to be, or the derivative of v is dv dt, and they jumped over here and they said that's equal to 14, but we'll worry about that later. dv dt is going to be equal to the derivative of 24h squared times the derivative of h in the inside. So it looks like they took care of the derivative of h, and now generally the derivative of this is going to be 48 times h to the first power. So if we look back at the question, we should always look back at the question. How fast is the water level rising? So we're going to be interested in dh dt. So dh dt is this. So in feet, we know that the height, so remember the height that they gave here is 8 inches. So we want to change that into feet. So we're going to divide by 1 foot is equal to 12 inches. So divide by 12. So it's 8 divided by 12. But we can certainly simplify that, dividing by 4. And so we're going to get 2/3 is going to be our reduced decimal. So we have a value for h. We have a value for dv dt. That's 14. And so we're looking for dh dt. So we have 48 times 2/3. Let's write this down carefully here. We probably should have written everything down carefully from the beginning, but here, let's actually take our time and write it down carefully. We have 14 is equal to 48 times h times dh dt. Okay, now we're looking for dh dt, so we can solve by dividing by this, or we can put in the value for h right now. So that might be a little bit easier. So let's take this and let's put in the value for h. And remember, the value for h is 2/3, I believe. And so 3 goes into 48 how many times? 16 times, maybe. Now, when in doubt, use your calculator. 48 times 2 divided by 3 is 32. So this whole thing is going to be 32. And we have 14 divided by 32, and that's what dh dt is going to equal to. So 14 divided by 32. Now I want a simple fraction, I suppose. 14 and 32 are both divisible by 2, so that's going to give us 7 divided by 16. And I think that's about as simple as we can get. All right, so that's the end of that problem.